Good afternoon, everyone. My name is Trevor Tisler, and as Florian said, I am a PhD student doing a co-tutel between the Center for Development Research at the University of Bonn and the School of Engineering at the Federal University of Minas Gerais in Brazil. And I am not an economist. I have a background in geography and environmental modeling. And I just finished, though, my first year coursework, crash coursework into economics. And today I'll be presenting to you about deforestation contamination in Brazil's ethanol supply chains under the National Biofuels Policy. And this is very preliminary. There's not even a working paper yet. The structure of this presentation is going to follow an introduction and contextualization of Renovabo, which is the Portuguese word for Brazil's national biofuels policy, because the context of it is very important. And then I'll present to you the research question and hypothesis guiding this model, the methodology that I have used for the preliminary results, the geographic study areas that I use, the results from those study areas, and then conclusions and future work. And especially I'm looking forward to comments from the audience on that to move forward, as this is only going to cover part of the first chapter of my dissertation. So, for those of you, let's define Renovabo. What is it? It's a mixed command and control regulation, which also has established an emissions offset marketplace. And this is Brazil's first carbon market that is fully regulated by the government. And carbon is traded in credits called CBIOs. Each CBIO is a 1 ton CO2 equivalent. And it's currently being traded on Brazil's stock exchange, the B3. So if anyone in the audience is familiar with low carbon fuel standards, and Renovabo is very similar to the infamous or the famous California low carbon fuel standard, which was the world's first low carbon fuel standard. Also, many of the European colleagues in the audience might be very familiar with the EU's Renewable Energy Directive and Fuel Quality Directive, which Renovabo shares a lot of similarities with that. For those who may not be aware of what low carbon fuel standards are, I'll highlight the main mechanisms that are involved in Renovabo. So first, there's 2 principal pathways that are involved in trying to reduce Brazil's transportation or the carbon footprint from transportation fuel. The first pathway is by setting mandatory biofuel blend concentrations for all fuel sold in Brazil, which is scheduled to increase from 2020 last year up until 2030. And as for right now, for example, in Brazil this year, gasoline is required to be an E27 blend with ethanol, and diesel is required to be an E10 blend with biodiesel. Now, with that though, in parallel, a second pathway is by requiring all fuel distributors in Brazil to buy the CBIO carbon offset credits. And this is determined by specific goals that are in line with Brazil's overall goal of reducing carbon intensity of fuel by 11% from 2020 till 2030. And moreover, by each distributor's market share. Now, these CBIOs come from life cycle assessments that are made at each biofuel producer's factory. From the field, from farming until distribution is part of the LCA. And of course, since we have first generation, second generation mixtures of, not only for ethanol, but biodiesel, biogas, and biokerosene here in Brazil. This means that each producer gets a specific environmental efficiency score or reduction of carbon intensity in comparison to ethanol against gasoline, biodiesel against diesel. And so then that difference, that environmental efficiency, is considered the carbon that has been offset. And while it's related to the amount of fuel that they produce, it's not 100% connected in a linear fashion. And then so, of course, as I said to you, the CBIO marketplace is the offset market where these CBIOs are sold in tons of CO2 equivalent. And the price has been at around $8, $8.40, I believe, in the past year since they were first started to be traded last year in mid-2020. So now, as I said, there's a connection, but they're not necessarily specifically connected, these two pathways of the blending requirements and the fuel that the biofuel producer produces, and then the CBIO credits that the distributors have to buy. And we can see that here, there's a connection. Right now, all biofuel in Brazil is sold in regulated auctions, but they are planning to make that almost free market open auctions soon. We'll see if that happens in the next 2 years. So no matter what, the fuel distributor has to buy biofuels to meet the blend requirements. But then also Renovabo, based on decarbonization targets, sets the targets based on a fuel distributor's market proportion from the year previously. And then the CBIOs are traded on the stock market, where biofuels or life cycle analysis is evaluated. It's decided how many CBIOs they are allowed to emit. Those are sold on the stock market, and the fuel distributor buys them. So these are two separate transactions. And to put this into context, I created a hypothetical explanation of this for you. This year, for example, the goal for the decarbonization credits is to offset 24.9 million tons of CO2. And say we have a fuel distributor that theoretically has 1.5% of Brazil's market share. That means that they are required to purchase 372.9 thousand tons of carbon offset credits. Now at the auction, they might be buying biofuel that comes from producer one, but some of the land that they use, and we'll get into this, may not be registered in Brazil's environmental rural registry, which is an automatic disqualification of biomass coming from those fields to be included in Renovabo. And moreover, they might have really bad carbon efficiency, right? It might be an old first generation factory, just hypothetically. So they are still required to buy these offsets. So instead they go to the stock market, and then theoretically they're buying maybe a mix of carbon credits from different producers. So there's definitely more biofuel produced in Brazil than there are CBIO credits proportionally. So now, with this, let's understand, why is Renovabo important? Well, first of all, this is one of Brazil's first and main principal bioeconomy strategies and policy. Secondly, there are direct links between Renovabo to Brazil's commitments to reducing emissions that it made in its first nationally determined contribution to the Paris Climate Agreement. Right? Brazil has made plans to, for example, by 2030, to make biofuel energy around 18% of the fuel or the energy market share in Brazil. And we also need to remember there's something important. Deforestation is a large source of Brazil's greenhouse gas emissions, but so is transportation. And right now, transportation is higher, or energy, excuse me, energy is higher, but historically, in the past 2 decades, deforestation was often the larger emitter, and now they're kind of battling it out. And with this, Renovabo and the life cycle analysis does not account for indirect deforestation, and it only accounts for direct deforestation that occurs after 2018. And I'll get into this more in detail in a bit. Now, I mentioned that this environmental rural registry, CAR, as it's called in Brazil, is important for Renovabo because that's the first kind of decision tree bifurcation that decides whether you are a biomass qualifies for getting counted towards CBIO credits or not. So you can have, after life cycle assessment, producers that only 70% of the biofuel that they produce, I've seen as low as 40, 30% are able to be used to emit CBIO credits, where the other part is not. But all of that, no matter whether it's linked to a CBIO credit or not, is sold in these auctions for blending. And the CAR database is very important because it's legally going to be and is Brazil's main land use environmental compliance verification tool. It's also a major tool for the biodiversity conservation goals for the CDB and post-CDB or post-Aichi framework that's still being formulated, right? It's also a tool that's been used for any REDD+ programs that may develop in Brazil. And it also is going to be used for potential legal reserve marketplace and ecosystem services marketplace in Brazil. So it's a very important tool. And this connection then is connected to Brazil's two main land use laws, which are the 2006 Atlantic Forest Protection Law and the 2012 Forest Code. So these are the main laws and tools that guide Brazil's international environmental commitments and definitely will have an impact on whether Brazil is able to achieve its NDC commitments to the Paris Climate Agreement. And these specifically, and in the legal context and in policy, are supposed to be limiting and stopping deforestation. Now, Renovabo is linked to, as I already mentioned, a lot of those multilateral environmental agreements, specifically the Paris Climate Agreement and emissions. However, there are deforestation loopholes. Even though there is an LCA, there is no accounting of indirect deforestation, and there's poor accounting for illegal deforestation that has occurred before 2018, which between 2006 or 2008, depending on where you are specifically in Brazil and what biome, has to be recovered by the end of Renovabo as well. It has to be recovered by 2032, or the process of recovering and regenerating that land with natural vegetation cover has to be started by 2032. And that has not been taken account of. So here's an example, and I'll just go through this, but this is an example of the loopholes. All right. Was there deforestation on the property after 2017? No? All right. As long as that property is registered in CAR, it's allowed to be used, even if there is illegal deforestation, or even if that property is not meeting what are called legal reserve requirements, the minimum amount that a property must be covered by vegetation. And that varies depending on biomes. And so with this, this is creating the potential for, leakage of carbon from deforestation, but moreover, the avoidance of legally required carbon sequestration services. And I'll just go through this because I think you get the point. So an example of this, and specifically with the legal reserve, is if we have a property that is in full appliance, and I'm using this as an example, part of the Cerrado has a requirement that 30% of all these properties are covered by native vegetation in a defined legal reserve. Say if there's sugarcane for ethanol being produced, and then there's another non-biofuel biomass intended activity occurring, the property's fine, and this property is allowed to participate in Renovabo, which makes sense. All that biomass can be considered as helping produce carbon offsets. However, the loophole also allows for properties like this, where as long as sugarcane is grown on a property and it is grown in an area that was not directly deforested after 2018, legal or illegal in the past, and illegal is the problem, and if that property is still using that illegally deforested area for non-biofuel activities, all of that sugarcane is still considered to be appropriate to be used for generating carbon offset credits. So my research hypothesis, after that long introduction and contextualization, is that, my question is, how much of Brazil's sugarcane cultivation area may fall into this loophole? And moreover, how much of this area could be supplying environmentally incompliant and deforestation contaminated sugarcane for ethanol eligible CBIO crediting? And I'm specifically just focusing on ethanol because of the land use data. But as I said, this is a model that's a work in progress. And if I can, I will love to try and incorporate soy sourcing for biodiesel, but I don't know if that's going to be possible. So as of right now, for these preliminary results, we hypothesize that the contradictions between Renovabo and the environmental law, Brazil's environmental law, have made a non-negligible area of Brazil's sugarcane cultivation contaminated with greenhouse gas causing deforestation or prevented carbon sequestration services. So with this, my methodology first included a legal analysis of all the laws and regulation that govern what land area is acceptable for under the Renovabo program, and moreover, all of the legal requirements for native reserve, or excuse me, native vegetation, land covers, and legal reserves. And just to show you here, one of the things that I discovered is that the literature often uses a very plain and a very general classification of these laws. And that could be detrimental because I was able to find data in native vegetation physiotyping that would allow me to actually map the law at finer scales. And as we can see here, the laws, especially in the Cerrado, of what determines 35% versus 80% legal reserves, is much difference with finer grained data. So with this then, getting into that, my methodology included finding sugarcane data for the past 20 years from IBGE to identify my study areas. And I use study areas and not nationally because of computational constraints, but I aim to go nationally in the future. INCRA and IMA-FLOR to get data for Brazil's rural environmental registry, as well as the Brazil's Forest Service to get data to help with the legal interpretation, and then Project Map Biomas to get land use data from 2019 and also important years under the legal framework, 2006, 2008, 2012, which included specific classified sugarcane. And then through this, I followed a general geoprocessing approach where I was able to put all the spatial data in a geospatial database, feed that into an area calculation algorithm from ArcGIS that specifically measured all of the relevant land types that I was looking at to determine whether how much native vegetation there was, how much sugarcane there was, how much other crops there were potentially on properties that grow sugarcane. And then I fed that into an Excel macro that I used to actually code the law. Now, in the future, I plan on doing all of this in R just to make it completely open source. But for the preliminary methodology, I followed this approach. So these are the three study areas that I use, and I selected them specifically because study area 1 is an emerging sugarcane area that did not have a significant amount of sugarcane 10 years ago. Study area 2 is a sugarcane growing region that has become consolidated within the past 10 years. And then study area 3 is actually an area that has been in the northeast of Brazil that has been growing sugarcane since colonial times. So through my methodology and running the models, I found that study area 1 has an overall legal reserve deficit, a deficit of native vegetation cover that those sugarcane properties are required to have at 19,000 hectares. And of this means that for all those sugarcane growing properties, they are 6.7, they are at a combined 6.5% deficit for their legal reserve quota. All right, this means, moreover, I've identified that there's possibly up to 3,900 or 3.9 thousand hectares of illegal deforestation that has occurred under the mandates of the law that Renovabo is not considering as a potential fine or not using to decide whether they can participate in the program. And moreover, because this is still in development in Brazil, if all of this native vegetation regeneration has to occur on the property level, if a marketplace for trading within specific hydrological basins is not established, then up to 8.9% of that area's sugarcane growing land might be reduced to meet requirements. For study area 2, we have a deficit of 76.5 thousand hectares. This is the combined deficit is 27% below their legal reserve quota. I estimated around potentially up to 8.8 thousand hectares of illegal deforestation. And again, under that scenario, the maximum potential cultivation area that could be lost of sugarcane cultivation for environmental recuperation could be 16.5% of that area. And finally, for the last study area, and then to wrap up after this, study area 3's legal deficit or legal reserve deficit is 9,000 hectares roughly. That means that that area or those properties have a combined deficit that is 16 or 15.6% below their required covering. There's an estimated 5,300 hectares of illegal deforestation that could have occurred. And just so you know, this area is fully in the Atlantic forest biome, and there is no such thing as legal deforestation in the Atlantic forest. The biome is so degraded that environmental protection laws do not allow any deforestation of primary or secondary forest. And because of that, that means that there could be up to 36.8% of that area's, because of that specific rule, it's a bit higher, of that area's sugarcane cultivating land that might have to be restored under the forest code. So with that, the conclusions. Now this is a very qualitative conclusion. I haven't been able to do statistical analysis yet because Sao Paulo, I decided not to touch them in Sao Paulo in these preliminary results. And it is known that Sao Paulo has major legal reserve deficits. But just doing kind of a qualitative analysis of the numbers thus far, it is possible, though highly likely, that up to 20% of Brazil's cultivation area of sugarcane might have to be restored for native vegetation to meet the environmental compliance deadline set by the forest code. And from this preliminary analysis, we believe that further investigation is definitely warranted to analyze deforestation contamination for all of Brazil's biofuel production chains and supply chains. And moreover, this is really important for making sure that Brazil's first carbon market is not dirty and tainted from the start. So with that, my future work, now that I'm recovered from my PhD courses, will focus on trying to calculate spatially explicit carbon deficit and sequestration deficits at the property level. Moreover, developing a supply and demand model to try and see how this contamination could be affecting those property owners and biofuel producers that source from farmers that have high compliance with the law, and moreover, how this could affect Brazil's biodiversity conservation goals in the future. So with that, I thank you, and I look forward to hearing from you.